Hey everyone, I'm Maverick with OwlKnightsMedia, and today we're going to go through an official Godot tutorial on their website in their documentation section. It's called Dodge the Creeps. We're going to do a section of it first, just to get our feet wet. I'll be going fairly quickly over the text portions, but I will explain core concepts and a little bit of what happens with the code, so let's hop right in. On their website, if you have it full screen, it'll look a little different. This is their mobile version. Let's go ahead and go over to Docs. In the docs here, they indicate the version of Godot, and we're also going to be using 4.2 for this. I'm going to go ahead and hit the menu, go over to Getting Started, and then click Your First 2D Game. Here's the game, Dodge the Creeps, where you move this little eyeball alien around, you rack up points the longer you're alive, until inevitably you hit a creep, game over, restart. Alright, simple enough. Core requirement, of course, is having Godot installed, and they also offer you this download of a zip file with a bunch of their assets. So you click that, make sure you unzip this. So I'm just going to do this process again where I extract all. I'm going to extract it right in place, and now I have those extracted, unzipped files that I can copy. Okay, good. Let's keep going. And they say setting up your project. You're going to click new. You're going to name this Dodge the Creeps. And find a folder path that's going to work. Create. Godot does Godot stuff for a moment. And here we are. Now I am going to try to resize the screen so we can see both at the same time. All right, good enough. Normally I work on two different monitors, but I want you guys to see this both at the same time. Okay, now their documentation goes on and says, put those assets you just downloaded into this file directory. They don't get too specific on how to do that, so we're just going to right click in their file manager section and open in file manager, which will open my operating system file manager, which I find easier to work with. I'm going to Control V, which is just paste those assets in, and in a moment they update into the Godot engine. Easy enough. And before we get too far ahead of ourselves, they also talk about setting up the project settings and going to their window, display window, and they have you override the default size with what they have as the width at 480, so we'll type in 480, and the height at 720. Okay. These little arrows mean you can undo that in a simple click, which is pretty convenient. Down here, they also have you change stretch mode to canvas items. Moving on, they talk about the organization of the project. This is just demo, so not too important. Then they hop into creating the player scene on the next page. So they say, click this other node and create an area 2D. So when you click other node over here, it gives you a search, and you can start typing in area 2D. There it is. The more you type, the more it filters. We'll go ahead and select that. And here we can see the little area 2D outline of the window size itself. You can see that it is vertically oriented, so that matches the settings we just changed in the project. So cool. Now we can't see anything yet because we haven't added anything to this area. It's got a warning that tells you, hey, this is an area, so in order for it to detect other areas, it's going to need a collision shape. So we're going to end up adding that as part of the tutorial, and they have you also press this group, which is not necessary, but it's a nice safety where you're going to lock everything in this scene tree, all the nodes in there that we end up having, so that you don't actually move one and not another. That's all that really does, and I generally don't use it, but the tutorial does. All right, now we get to the exciting stuff. They tell you to add a scene, or excuse me, they add a node called an animated 2D. Animated sprite 2D here, which also needs something, and that's why we're getting another little warning. And it needs, if you click over on the right hand side in the inspector, sprite frames. So we're going to create new sprite frames. I'm going to click off and back on so that it auto populates the animation sprite frames we just created. And then they tell you to go into the art. Let's scroll down a little bit. Go into the art and grab the appropriately named pictures of the little eyeball alien. So these two gray ups, gray up 1, gray up 2, and they name that up. They create a new animation by clicking that paper icon, and they call it, I believe they call it walk. Okay, and you put the two little walk things there. You can preview them by pressing play. Pretty cool, very neat. I'm gonna go ahead and stop that for now. All right, animations are in there. Sprite is huge, and they talk about that because this is the outline of the screen, right? So that's a massive character. And if I were to skip ahead and save this, well, let me name it like they do. They name this player. If you ever lose track of what type of thing you've renamed is, right? It used to be Area 2D. You can hover over it. It'll show both the name you just selected and the type that it actually is. In this case, we named it player and type area 2D. Cool. All right, now let's save. I'll go ahead and press enter. So it's saving that file down below, player.tsn or player scene. And we can see that, yeah, that character is huge compared to the screen. It's in the upper corner because that's the default position of any new node. It's going to be on the perfect axis of X and Y. We could move it, but since this isn't the game scene, this is just the player scene, we're going to leave it where it is. But we can see that it is huge. So they have you resize by going and selecting the animated sprite 2D, going into the node transforms, and the scale is set to half, so 0.5 instead of 1. And we can see that that little character got smaller. So simple enough. Now they address the other yellow icon where we need a collision shape. So we start typing in collision shape 2D. There it is. I pressed enter. And that collision shape also doesn't instantiate with everything it needs. So you have to go over to the node inspector and select a new shape for that collision, for that area that's going to detect or collide with other areas. They have you make a capsule 2D. And then I'm going to zoom in with my mouse wheel here. Make sure that I'm selected on a selection mode, which you have select mode, move mode, rotate, scale, and some other symbols. The first few are the ones I use most often. We're going to drag this down. And because it's a capsule, not a circle, we can do one at a time. And that covers the character so that that area can now be an interactable collision shape and not just a picture on the screen. So animated sprite 2D adds the animation, collision shape detects things. All right, cool. We'll press save. And now we have this character. It can detect other things. Simple enough. Moving on, when you're finished, the player scene should look like this. Ours does. Cool. We'll click next. Now they're going to add code, make it do things. So they say click the player node, top level node here, and then hit the little paper icon, which will attach a script or a file that we can put code into. We're going to let it auto-generate. It's with a template and just hit create. And it comes with some boilerplate, which they get into, but honestly, the commentary on the boilerplate explains it too. But we'll get there in a moment. So if I scroll down, we'll see that they add an @export, which makes this variable both visible to outside nodes and we'll add it to our inspector. So take note here on the right, we have an area 2D as the starting spot. We're going to @export a variable that we're using GD script, which they also offer tutorials through their website on how to use it and how it works. For now, we'll keep moving. Variable for speed, and they set it equal to 400. Once that is detected, we can see on the right hand side in the inspector, now we have the speed variable that we could adjust directly using the interface instead of strictly the code. And so that's a pretty cool thing to have with the export. I'm going to set it back to where it was and follow along with their code. They also declare the screen size variable, And what they're going to end up doing is taking that screen size, and once everything is ready in the game engine, especially this node itself, we're going to detect whatever the screen size is so that we can use it later to prevent the player from going out of bounds. If I had one critical feedback point for this tutorial in general, is that a lot of it, as you're going through the first time, is just, okay, copy paste. I have no idea why we're doing this. And then they get to the why later on. And it feels very much like they made the project and then they just put the instructions per file. So they do all of the player code, for example. And then later they attach things to make some of that code work. As a regular developer or even as a hobbyist, it's more natural and intuitive usually to implement something at its base form, like a minimum product, and then add features to it over time when you're ready to do so instead of all at once. That's my only critique of this tutorial, and you'll see this happening as we go. But with that out of the way, let's keep going, and I'll do my best to explain things as they add it. Okay. They talk about the ready function, which happens when you initialize this. Can't quite see everything I want to see, but I'm afraid to take up too much more screen real estate. But here's this code comment where it's called when the node enters the scene tree for the first time. Fancy way of saying once it enters the game or the universe, this happens once before all of its other functions. All right, pass allows this function to not be erroring out, because if it has nothing in the function, it'll try to detect the next line. So we don't need pass once we add some lines. So we're going to take that screen size, and now that everything is ready, we're going to use the built-in getViewPortRectangle function that gets invoked, hence the open and close parentheses, and then we're going to take that, what that returns, it returns a value, and we're going to get the size of that. All right, and we can see that without pass, this still works. We don't need it, and that's fine. Also, I'm not a fan of double spaces between things, but you'll see that a lot in their editing and online tutorials. All right. Then they stop coding for a moment and they say, oh, by the way, let's add some custom inputs. So they're going to add up, down, right, and left. So the way they do that is they click project settings. They go over to input map, and then they type in the name of whatever they want their custom action to be. You could name this anything like rainbows, but for now we're going to use what they use and move right. You can click add or enter on your keyboard. So move left, we're going to have a move up and a move down, right? Now these don't do anything unless you map them. So if you click this plus sign, it will start listening to input. So I'm going to put this as right. I'm going to do WSAD, so D for right. And we're going to do the same thing for left, up and down. Now you could keep adding things here. For example, if you had a controller like I do, as long as it's on, we'll turn this on. I'm a fan of the PlayStation 4 controller, but any will do that hooks up to your system. So I'm going to hit add on move down, press down on the D-pad, and we can see that it detected that. I could do down with the joystick and it detects that as well. So you can map as many or buttons or keyboard inputs as you want. For now, we're going to keep it simple like they do in their tutorial. And you don't have to save this. It's already saving because you're editing the settings themselves. So we'll go ahead and close that. And that should already just be built in, and we'll prove that when we go to move the character. So let's keep moving down through the tutorial. And now they go back to coding. So back into this file for the player GD or player GD script. And they change that process function to where they're declaring a variable in here of velocity. And they're going to, velocity is a vector 2. A vector 2 put very, very simplistically, oversimplified. You can read on their docs more about it and on the internet. Is effectively going to take two arguments, the first one being like a horizontal x-axis argument, and the second one being a y vertical argument. Important to note in game development, at least in the Godot engine, positive numbers on the y-axis are non-Euclidean, so not like in math where like you have a graph and going up like your stocks is a positive number in y as opposed to a negative one. In games, it's the opposite. So x is still positive left and right, but y is actually negative up and positive down. So if you're coding and things are working opposite vertically, you probably just have your y values flipped. So this is going to take an x and a y. So knowing that, they have built-in helper attributes that you can declare vector2.0. And all that's really doing is basically writing vector2 with an argument of 0.0 and 0.0. So instead of having to write that out, they make this shorthand of vector2.0 and they make that available. Similarly, if you just wanted to go right on the x-axis, that first argument, so you'd have like a vector of 1.0 like that, you could write instead, you could do vector dot right. It's just a shorthand, so figured I'd call that out. All right, their documentation here declares that. So you start with 0 velocity, makes sense. And then they start detecting for the input from the player. So they put an if where they're saying if this happens, right? And then they're using built-in input in the system, knows what that input is, and it has various functions you can use. They're using is action pressed. And it pops down a nice pre-generated list, including these ones that we just manually added to the project. So that's pretty convenient. And they start with move right, and their if blocks end with a colon, new line, if velocity x, so if the horizontal movement, if you're pressing right, whatever right you mapped, in our case, D, if you're pressing that, then we want to make the velocity's horizontal axis greater than it was. So plus equals 1. For most coders, you'll recognize that syntax. For non-coders, plus equals is the same thing as writing velocity.x equals velocity.x plus 1. So instead of typing that all out, they have a shorthand. And so they're going to do the same thing for these other lines. So I'm just going to copy this first one. And instead of move right, if I delete that and press Control Spacebar at the same time, I'll get that drop-down list. And so we'll do move left. And I'm just going to put a comment here for right now and paste these other two. We're going to replace them and then fill them in. So instead of move left, then they do move down. And for the last one, they do move up. Okay, let's make sure we don't forget to actually enact those changes. So velocity.x is going to be negative equals 1. Opposite of right would be negative in this case. And then we talked about the y movement being opposite in game development to normal math wise. So in this case, it's going to be velocity dot y, not x, and it is also going to be plus equals 1. But again, notice that that's for moving down. So easy mistake if you're not used to game development. I still make that mistake because I'm old. All right, negative equals 1. So that's kind of cut and dry. Don't want to go too deep into that. They have another if block where their velocity, if they're detecting any length to the velocity, and that's a function, so that's why they're invoking it. They're saying if this velocity vector has any length that's greater than 0, then we want to make sure that it's normalized. So they take velocity equals velocity.normalized, and they multiply it by the speed. So basically, if the user has input, you're going to have a velocity that's greater than 0, and that velocity needs to be normalized. What is normalized? So if you know Pythagorean theorem, a squared plus b squared equals c squared, well, that c squared is longer than the other two sides, right? And so what happens in video games is we move up, down, left, right. So when the player presses up and right, they move diagonally, but they actually move diagonally faster because it's a longer vector. sounds complicated, but you'll get used to it. It's a longer vector diagonally. To compensate for that, they've added a normalized function to automatically crunch it down so that when you do move diagonally, you're not moving faster than if you're moving up or right. So that's what that function does. They then use a $, which is a shorthand, so you don't have to import something in your scene like these other nodes, which is exactly what they're referencing. So they're referencing the animated sprite 2D. Of note, this only works if the name and spelling and capitalization is identical. It needs to be exactly the same here. If I rename this animated sprite to face or something like that, I'd have to name it face here. So be mindful if that's breaking, it could just be a typo. And they're saying get that animation sprite and play the animation. .play is a built-in function for animated sprites. And if you ever want to learn more about any node in general, I love their search help. So you press F1 on your keyboard and it'll bring up their search help. So here I'm going to just type in the play as a function, and I can see that this entry of the documentation is underneath that animated sprite 2D. I could click that play and it pulls up the documentation about that method and tells me about what it does, what arguments it takes, and it's really, really useful. Especially as a developer, having good documentation goes a long way. Segue aside, let's get back to what they're doing. Okay, if we have velocity, do this. Otherwise, else, we want to take that same animated sprite and we want to stop playing animation. So if we're not moving, the player's not pressing any input, the velocity should be not greater than 0. So stop playing the animation. Moving down, they're explaining a lot of the stuff I explained, but they also have this code here that I'm just going to copy and paste. And I'll explain what this does here in a second, where you're doing all these calculations to determine what the velocity of the player is, you know, how fast they're moving and where. But you also need to tell the game engine, okay, I've calculated all this. Now actually move the character, change the position of the player. So you have to explicitly do that. And so that's what position is. It's a built-in variable that's detected in this node. And we can see that we haven't declared it like other variables up here, like velocity had to be declared as a variable. Position is already built in. And we're assigning it to velocity, and we're multiplying by delta, and they kind of describe it a little bit in the auto-generated code, where delta is the change between frames. To simplify that, if you don't adjust for the delta, that change in position is going to happen as fast as the computer can handle it, which is really fast. So your player, when you press right, will just go whizzing off the screen instantaneously because the computer's really fast. So to make it happen kind of like on a frame basis instead, and standardize that movement a little bit, they use this thing called delta. It's kind of complex. I barely understand it myself, but that's what it's doing. The second line here is where they're clamping the position. They're limiting the possible values of the position. So you guys may remember we declared the screen size. Well, that is so that we can clamp the movement of the character from 0 to whatever the screen size is. So I think we can probably play this. Let me just, they start going into the animations here. Let me see if we can play this. So I press F6 to play the scene. And now if I press WSAD on the keyboard, we can move this character. We also see when he stops, he's not animating. And when he moves, he's animating. Now we might notice that he's not animating differently up, down, and left, right, even though we made 2 different animations. And they get into that a little bit here. So you can also press F8 to stop that. So F6 to start a specific scene, F8 to stop a scene. Choosing animations. So they add this code. And to keep this tutorial as brief as possible, I am just going to copy and paste it here. Just be very careful about indents when you copy and paste. So this is all indented, but the inside of that if block needs to be indented. So I'll indent that. There we go. And the inside of this if block is indented, but the whole block isn't. So I'm going to indent that by pressing tab. There we go. All the error is gone. So what does this do? It's saying if you're moving horizontally, velocity.x, then we want to play the walk animation, and we want it to be false for the vertical flipping, which is weird if you don't realize that later on we could flip the vertical. So, you know, it's weird getting it like this, but this line makes no sense on its own. It only makes sense when you realize that they changed it later. And then they also set the flip horizontal based on the result of if your horizontal value is less than 0. So it's like basically an if block and an if block, but they wrote it as a Boolean, which is a true or false statement. Down here, the elif or else if. So it's an if else, but with an additional condition. And then they do, instead of based on the horizontal movement of the x, they do it based on the y, the vertical movement. And otherwise, it's very similar logic where we want to play an animation, flip it if it's on the negative value scale. So when we want to go up, if the player's pressing up, the up animation should play. We're going to use that same animation because it's the same image, but they, instead of making a whole new animation called down, they invoke this flip vertical where it just takes it and flips it vertically for when the player's pressing down, or doing the opposite y value on the axis. Same thing for the left right. So that's a little confusing at first, but let's go ahead and press play, see if it does it. You can see that now the head faces down when we travel down. Flip V will flip it vertical when we press up. It is the same animation, so they're just cutting their work in half. Same thing for left right. You can see that the little eyeball is flipping, but it is the same animation that's just been flipped based on the value, positive or negative, that it's detecting. So that's what that code is doing. Moving down, let's see what they're doing. They say, go ahead and add hide to the ready, which is going to make this character invisible as soon as it enters the game. So we'll add that. I'll press F6 and you can see that the character is missing. It's just not there. I find this weird. It's that out of order sequence thing that I was talking about where they're preparing for the future even though we're not really there yet. So that can be very strange, your first go through of this tutorial. But that's what it's doing. It's preparing for when they have like a start screen. You don't want the player in the background or to be able to be interacted with in a meaningful way showing up while you're on the start screen. So they just hide the character. That's their solution here. Fine, trust fall, we'll do it. Similarly, they're going to start preparing for it to get interacted with and potentially killed by the enemy by adding a signal to this script. So at the top, if you type in signal, which is a keyword, it shows up as red. So they're like, they're special words that the Godot engine will detect. This is very common in most coding environments. So if you type in signal, it should appear red, and then hit is the name that you're defining, right? It could be hit anything. It could be hit rainbows, hit whatever. All you're doing is defining a custom name here. So in this case, they're defining hit. We'll save that. And if you go over to the right and go over to the node portion of the inspector, let me click off and click back on the player, you'll see that now that node has this extra signal hit in addition to all these other ones. So now we can use that as if we were using built-in ones whenever we want, and they will use that to detect when the player's hit. They then have you connect the body entered built-in signal for the area 2D that we're working with. What do they connect it to is the question. Let me take a moment to refresh myself. I think they actually just connect it to itself, but add this code to the function. All right, we're not going to do that just yet. I need to know what we're connecting this to. This signal will be emitted when a body contacts the player. Click connect and connect a connect a signal window appears. Yes. Godot will create a function with that exact name in the script for you. You don't need to change the default settings. So they're not actually specifying where you're connecting. So I know that they're probably going to connect to the player, but it's strange that they don't specify that. So let me explain why that's a bit confusing. So they're using body entered. Okay, so we find body entered, double click that. And you have a limited amount of choices here, so I think that's what they're just assuming. But you could really connect this to any node that you want. So I kind of find it strange that they're not more explicit about that. But let's go ahead and double click this player, and that connects it. We can see that it's connected a couple ways. You have this little emission icon on the left-hand side, letting you know that it has a signal connection. If you're in the node inspector like we are, we can see that now there's this little green arrow. And if you're in the script that is connected to that signal, you can also see a little green arrow indicating that there's a connection. And this logic, they don't know what you want to happen when a body enters, but they tell you in the tutorial that you're going to add this code. So what is this doing? It's hiding the player's node. It's emitting that custom signal we made called hit to let the game in general, hey, somebody, whoever's going to be listening to my custom signal, I've been hit. So it emits that. And then it detects its own collision shape 2D. It detects that with the $, and it invokes set deferred, which we'll talk about in just a second. And it's saying when a body enters the player, so when there's a collision basically, we want to set disabled on our collision body to true so that things can't keep colliding. If we hide the player, we don't want other things still interacting with it. In theory, just because you're not visible doesn't mean that your collision doesn't exist in the game. So we're disabling collisions, and the set deferred portion is there because if you have multiple collisions happening and then you suddenly hide the character, that can, or excuse me, and then you suddenly disable the collision, if it was calculating something else, it'll cause an error because you're calculating something and then poof, it's gone and you're not done with your calculation. It doesn't know what to do. So set deferred says set disabled to true, right? The arguments in the parentheses here. Do whatever I'm telling you to do once you're ready to take a new calculation. So if it had been colliding with multiple things at once, it could be doing all sorts of calculations. We don't want to interrupt that. We're saying when you're ready, go ahead and set yourself to disabled. So that's what set deferred does. This would be very similar to typing collision shape 2D and then invoking disabled, which is a built-in attribute to that type of node, to true. Right? So that's effectively the same, but we're handling an edge case in this scenario with the set deferred. So that's what all that's doing. And then at the very end, they say this last piece is to add a function call we can call to reset the player when starting the game. Again, the out of orderness is weird. Restarting the game or starting a new game implies that we can even start the game. They haven't created that yet. So I find this order of operations odd as a developer, but we're just going to go with it. So they add a new function called start, which takes in an argument of position. So you're going to pass the position you want the character to start in when you invoke this function. And it's going to say take the player character's position and set it equal to the position that gets passed in by whatever's invoking this start function. Then we want to show the character because it's probably hidden, which happens when it collides with another object, and it also happens by default. So we want it to show when they start the game, and then we're again referencing the collision shape, their interaction portion of this tree, and we're setting disabled equal to false. Basically saying, since we're showing the character, we want it to be able to interact and collide with other things. So that's what all that functionality is going to do. I'm going to press F6 just to make sure I didn't typo anything and break the game. And I forgot that we're hidden by default, so Control// will comment something. I'm going to press F6 again. Character still works as intended, so all that extra code is there, but it's not doing anything meaningful yet. The signal means nothing to us yet because there's nothing to collide with. The start function means nothing because there's nothing to start the player, but it's all there. They're preparing for the next few lessons. So I'll go ahead and uncomment that, Control-S to save, and that ends the create the player portion. I don't want each of these videos to be super long. There's only going to be about 3, so this is making the player. The next one will be making the enemy, and I believe the third part of their tutorial is creating the heads-up display. So next time we'll get into creating the enemy. Thank you for following along. If you have questions, please leave a comment, and I hope you like and subscribe, but either way, have a good day. Thank you.